This is brainfuck. It's an entirely esoteric programming language that is pretty much used for nothing other than just to show off how big your programming balls are, and also to just get you thinking in a different kind of way when it comes to programming. And on the contrast, this is JavaScript. It's completely native JavaScript. It runs in the exact same engine that all the JavaScript will run in whenever you access 99% of web pages that have JavaScript embedded on them. It is literally the exact same thing. It's just written in a very specific way called JSFuck, which only uses 6 characters. Now, it's not actually useful for anything. No one would really want to write code like this. It would be completely impractical and just terribly imperformant. But the point is that it's a really good learning tool for understanding a few things about how JavaScript works, but it was also used as an attack vector at some point against eBay, and no doubt there's been other sites in the past to avoid how they block certain JavaScript from being run on their page. That being said, it's unlikely that we'll ever see many uses for this outside of just being a good learning tool, but hey, it's a good learning tool. So I'm going to waste no more time and get straight into this. The first concept we need to understand is that JavaScript is a dynamically typed language, meaning that the types that you create don't have to be defined. So in a lot of programming language, when you create a variable, you have to define exactly what type of data is going to go into that variable. So if you're creating a new variable and you want a string to go in there, you have to specifically say, this is going to be a string and it cannot be a number. If you try and put a number into a string variable, it's just going to crash on you and say, no, I'm not doing that. So in JavaScript, it's not quite the same. We can create a variable and just put anything we like in that variable, pretty much. And JavaScript is completely okay with that, and it's going to try and handle whatever you put in there however it thinks it should be handling it, which is really where the abuse comes in that allows JSFuck to exist, to write JavaScript using only 6 characters. So this variable hello could be number 1, it could be a string of hello, it could be anything, and JavaScript will say, no problem, I'll deal with this as it comes. The first challenge we will try and overcome is to just create a letter using JSFuck. If we could just get JavaScript to try and interpret the letter A, we're probably off to a pretty good start. So one important concept we need to understand is the concept of typecasting. It really isn't crazy complicated in JavaScript. It just means we're changing a value from one type to another. So for example, here we have a number variable and we've assigned it 5, but we've assigned it as a string. And when we try and add 5, as I'm sure everybody is fully aware, we get 55 because it is just adding those two together. It's concatenating them. This plus operator just believes that it is trying to add 2 strings together, and that's what it will do. So one thing we should really be aware of that will help us to understand how JSFuck works is that we can force types. So what I can do is just wrap this around this number wrapper, and this will turn this string into a number, and when we run that, it says we're going to deal with this string as a number, and then when it gets down to logging that out as a number, it's going to do that operator as if they are 2 integers, 2 numbers, instead of being 2 strings. So now we understand what typecasting is. We're literally just changing a value from one type to another, but we can use that to our advantage because what we can create is an empty array. Now, an empty array is considered true in JavaScript. There are a list of only a few falsy values, things like 0 and undefined, that JavaScript considers false, as in when you convert those or typecast those into a Boolean, it says that they're false values. But anything outside of that list is going to be considered true, and this is outside of that list, an empty array. So if we use the wrapper we used earlier, but this time we use the Boolean wrapper, and we turn this array into a Boolean, we get a value of true. Now we obviously can't use the word Boolean because it is not part of the 6 characters we're allowed to use as part of JSFuck, but what we can use is an exclamation mark. Now, when we use the exclamation mark as an operator, it's going to act as the not operator, which is going to reverse any Boolean that precedes that operator. So if we give it a true and run that, it gives us a false because it's saying it's not true, meaning it's false. So what we can do is we know that this operator expects a Boolean, and because JavaScript is dynamic and is trying to make nice assumptions for us, we can abuse that fact and just give it our empty array, which we already know would be converted to true, and then negate that to turn it to false. So now if we run this, we have the word false. Now, if we want to turn this into true, we can just simply add another not operator. So we're just saying it is not false, which means that it is true. We obviously need that initial operator there to turn it into a Boolean, to make JavaScript convert that for us, and then we're going to flip it back around and go for the opposite, which is going to be our true. So why exactly is it important for us to get the Booleans true and false? Well, these are going to be our starting grounds. We'll use these a lot. We can now begin to get any number we like, because if we take a Boolean, for example, false, and we manually convert that into a number, we now have the number 0, and if we have true, that is considered the number 1. This is just how JavaScript is going to interpret these two things. It thinks that false is 0 and true is 1. So we already know how to get true and false, but we don't know how to convert things to a number. Now, fortunately, one of the few characters we can use is the plus operator, which actually serves as two different operators. There is one operator where it is going to take two things either side of it, either two strings and concatenate them, two numbers and add them together. There may be even other uses, I don't know. But there is also the unary plus operator, which is just going to take whatever precedes that token and just turn it into a number. It's just a very, very short way of using exactly what we just used. So this obviously returns us 1, just like we tested. Now, if we just replace this with our plus, which is our unary plus operator, again, it changes it to a 1 for us. So now we know how to get the numbers 0 and 1, because we already know how to make true and false, and we already know how to turn those into numbers, which are going to give us 0 and 1. So if we create a Boolean, convert that to a number, this is false, so it gives us 0. We just negate that again, and now we have a value of 1, which also means we can make any value we like, because we can just simply add 1 again. Obviously, this was in plain JavaScript. We could just replace that with our JSFuck, add that again, and here we go. We have 2 using just JSFuck here. Now we have access to any number we like in JavaScript, but also true and false. Now, we can use this to our advantage because we can treat strings in JavaScript as if they're arrays. They're considered array-like objects. You could Google more information about those if you wish, but we can essentially access specific parts of a string as if they were an array. So if we take a string like hello, and as we would with an array, say we want the first element in that array, which will be with the index value of 0, this should give us an H, which it does. So now we're able to get specific values in strings. We need to start creating some strings to get values from. So this is the easy part. We already know how to do this. This is just square brackets and a number. We know how to do those. We already have square brackets available to us as part of JSFuck, but we want to start creating strings. So 3 important strings we can create are true, false, and undefined. We can create undefined in a number of ways, but this is easily one of the shortest ways. This will return as undefined. Now, if we go back to, let's say, false, since it's nice and short, now if we want to convert this into a string, we can simply add an empty array, because whenever we have the plus operator and we are trying to convert, it will look at that empty array and think, okay, I want to convert this to a string. And anytime you convert an array to a string, it just takes all of those elements inside of that array, and just for each element, it will just be comma separated, and it will just be one giant string of comma separated values of each element in that array. Now, since there are no elements in the array, we are adding a completely empty string to our false, which obviously is a Boolean, but our plus operator will think, well, we're trying to do something with strings here, we're trying to concatenate strings, therefore I will convert this false into a string and add nothing because our array is empty. So if we run false without adding an array, we get false as a boolean, and now if we add an empty array, as I mentioned earlier, we now get it as a string. Note how it's in black in the console log, and since it's a string, we can now access it just like we would a array, since it's an array-like object, as I mentioned earlier. Now this actually will not work because of operator precedence, which I won't go too far into detail about, you can Google that, but long story short, JavaScript isn't sure which order to try and do things in. So we can separate our operations using our brackets, because brackets in JavaScript have the highest precedence of any operator in JavaScript. So we're saying run all of this first, and then try and get something at the index of 0, which returns us f as a string. So now we have true, false, and undefined broken down into every character of that string. We can start using that to build strings. We have obviously any number we like and any boolean we like, true or false, so we can start to do some interesting stuff. Now obviously 0 is not allowed, so we can just convert this into our JSFuck by making a false and then converting that into a number, and now we have an entirely JSFuck written way of getting a character, the letter F, which obviously if we wanted we could then create 2 and get the second value, which would be A, and so on and so forth. But we have a very limited character set. We only have the characters from true, false, and undefined. So some important words we can create now are the names of some array methods. Since we already have arrays available to us using the array literal syntax of just 2 square brackets, we now have the ability to make arrays and then use the methods of those arrays. And what's that important for is that we can then use, for example, .fill is one we can spell out, which will return us the method header. Now obviously we don't have a dot available to us, which is the normal way that I would say 99% of people that are writing JavaScript will call a method, but we can actually use another syntax which is less frequently used but still useful if you're trying to use strings, which we are trying to do, to call those functions. So if we use the word fill inside of the square bracket notation, we're going to call the method fill on this array object, which means that we can get the exact same data without having to use the dot operator. Now with these extra characters, we have even more characters at our disposal. And one thing that we can use this for is to create the word constructor. So now we can create the word constructor, which will return us the constructor function of each object. We can pass in different types of objects and get the strings associated with their constructors. So for example, if we run this, we will see a number of different object types. We have booleans, we have numbers, we have strings, and we have an array. And this will return us those constructors. And obviously we can turn these into strings just by adding an empty array on the end. So as you can see, this is slightly different formatted to the rest because that is now a string. So we now have all of these characters to work with. So now we have a much broader amount of characters available to us. We could start to do some pretty interesting things. Most notably, since we were able to get the constructor for string, we're able to get a capital S, which lets us call the method toString. Now we already know how to change values to strings automatically using just adding an empty array and tricking JavaScript into converting whatever we give it into a string. But there is actually one very important feature that we can't get from that, which is the ability to convert the base of that output. So there's another parameter on the .toString function called the radix, which will allow us to define exactly what base we want that turned into. So for example, if we call .toString, we'll use the square bracket notation just to make it a little bit more realistic to what we're going to be using. Plus we will invoke it because it is a method or function. And this time we add in, so originally if we run this, yes, we get the number 10. Now if we want that in base 16, actually that will give us an A. And this also allows us to use 32. Base 32 is exactly what ASCII uses. So now we can just use these characters and get back any character we like in JavaScript using this. Just this will be, A, B, C, whatever. I missed 12, great. But you get the point, right? We can create any character we like in JavaScript because that is how ASCII works. Here is just an example of me running a bunch of different numbers through different bases. You can see how different the outputs are, but obviously base 32 is the one we're interested in because we can create any ASCII character from that. So we now have access to all the numbers in JavaScript, all the characters in JavaScript as strings that we like, booleans, whatever. We have access to so many different things at our disposal, but we can't actually evaluate what we are writing into code. At the moment, all we're doing is something similar to console.log 5, for example. And this is valid JavaScript. It's going to look through that code and say, oh, this guy is creating the string. I'm going to create some memory for that and put that string in there, but it does absolutely nothing with it. It's very pointless. So how can we create a function from a string? So one way we can do this is to abuse how inheritance works in JavaScript, in that we have objects that will extend from each other. So pretty much every object in JavaScript is going to extend from one base class, which has no prototype or parent, if you like, because it is the highest level, which is the object. And we can then extend from that. So function, for example, will extend from that. And then from function, we will get all of our methods, such as the fill on arrays, like we said. So we can use that link to go right back up to the function level and then use the constructor on the function object to create new functions. We already know we can create arrays, and we already know that we can use square bracket notation to access functions, which are the methods attached to those. So we can go, for example, with the fill, and we can look for the constructor for that fill just by going for constructor, because essentially, even though this is a function, functions are considered objects in JavaScript. So we can then go to the constructor for that object and then use that constructor to construct our own functions. So for example, if we want to go console.log and we want to console.log hello world, we will now automatically run that as well. So we'll invoke it with our curly brackets, and now if we run this, we are able to get a hello world out of this in our console. And then we have finally created code in JSFuck. This is actually not JSFuck, obviously. I've just written this out manually, but I'm not going to go through every single individual character and write this out in JSFuck. There is a million and one converters online that you could use if you are as lazy as I am. But either way, we could have used all of the methods that I've gone through here to write this out manually. It's just really an exercise in laziness. And obviously, or with the exception of our semicolon, but realistically that's not required in JavaScript. It's just, I'm the best developer ever, so you know, best practice just comes naturally to me. But yes, that's it. That's all we needed to do, and now we can write any code we want using JSFuck.